bottom line here, let's see. I'm going to call myself today Francis Scott. I think that's a name. Anybody heard of a Francis Scott in history? Francis Key Scott? I'm not a history buff, so I don't know. I think he's the one that wrote the Star Spangled Banner. Francis Key Scott. But I'm just going by my memory. Today is the first day back, March the 18th. What was yesterday, by the way?
17.
Was it special?
It was St. Patrick's Day.
It was St. Patrick's Day. I noticed some of you wore your green today to celebrate St. Patrick's Day for yesterday. And yeah, graphing, expo. Some call it exponential functions in 1B. All right. So let's see. My mind's a blur a little bit because I've not been studying anything. I tutored last night at somebody's house for calculus, somebody in my church. Graphing expo, it means exponential functions. And there's the word. If you want to really spell it out, there it is, exponential. The basic exponential function may look like this. Y equals b to the x. What's different about this versus like the quadratic? Look at what the exponent is. It's not a number. It's a variable. It doesn't have to be x. It could be x plus 2. It could be 3x minus 5. But there's a number down here. This is a number. That's a number. Nope, it's not a 1. If it's a 1, it'd look really silly. Because if y equals 1 to the x.
It's a 9.
Huh?
It's a 9.
A 9?
It's upside down.
Oh, upside down 9, yeah. The letter B is upside down 9. But since they're using B in this definition here, if this number down here is bigger than 1, we'll call it an exponential growth. You've seen exponential growth functions in biology. You've seen exponential functions when it comes to making money in the business world. If you're making money, how would you like to see the function look like? What would growing look like? Very much so. That's exactly what it says right here. And is increasing. Very good. It looks like this. There's my little picture here. It looks like this. It's growing. I should have used a different color. Let me back up and take that off. Let me use the blue. Let's see, here it goes. It didn't even do it. I think my iPad's on spring break. There it is. It's going to go climb up. That means you're making a lot of money. Or if you were raising rabbits, you're having a lot of rabbits.
Do we have to do that?
No, I'm just showing you what it looks like. You're going to see a whole bunch of them in a minute. What if B is less than 1?
Decreasing.
It is decreasing. You're right. It is decreasing. I'll put that here.
Decrease?
Yes, but we use a different word. Still starts with a D, though. Let's see.
Decrease?
I don't think you'll guess it. When you see it, you'll go, well, that makes sense. Exponential.
Wait, don't say it. No, decrease.
You going to try it one time? A D word? That means the same thing as what you said? If you're growing, you're alive, right? You're alive. You're growing. So if you're not death. Okay, think of death for a second. What does a dead thing look like after time?
Oh, decrease. The crow. Ah, that was
She's got it. She's got it.
Decay.
Decay. Yeah. You had it on the tip of your tongue. It wouldn't let you. Yeah, I know. Exponential decay. And of course, that will be the opposite. That as we go to the right, it actually does this. It decays. It approaches this y value of a 0.
So I was thinking about
Decompose, yeah. That's exactly the same thing as decaying. That's what decaying is. It's decomposing.
Because I don't know what the word. I never heard of decay. I only heard of the word decompose.
That's okay. You're doing good. Now, a new word that you may have seen, but I don't think we taught it in Algebra 1, asymptote. It's a line that a function, any kind of function, doesn't matter, approaches, but can never touch or cross. Well, I guess you can't touch it, how can you cross it, right? It's usually invisible. And when I graph an asymptote, I usually do it with a dotted line. And exponential functions always have a horizontal asymptote.
So that's the approach.
What's that? It approaches.
Like how you hold on. Can you zoom out?
It approaches but can never touch it. But the weird thing is, forever and ever and ever, it approaches it. Gets closer and closer and closer, forever and ever and ever, but never get to it. Okay? And the one that we're going to deal with, because they can be both vertical or horizontal. Vertical means up and down. Horizontal means left and right, like this, right? So all exponential functions have a horizontal asymptote. And if I was to just look at my two pictures here, I did two pictures. If I was to ask you, what horizontal line does this blue graph right here, what does it look like it's approaching horizontally but never will touch it? Any guesses?
The y-axis.
Well, it did cross the y-axis, the x-axis. Who said it? The x-axis, right here.
It's opposite.
Yeah. Well, I mean, we always mix up x and y. That's just human. We just say y, but you meant. I know what you meant. You meant this line right here. So I make it dotted to show you that it's also called the horizontal asymptote, because this function, as you go left forever and ever and ever, it keeps getting closer and closer. But if you use your calculator and zoomed in, you would see that it never touches. Oh, it looks like it touches now. Zoom in again. No, it doesn't. I'll give you an example with my power of the iPad. I'm going to start drawing a decaying function that's approaching. Kind of looks like it's touching the axis, doesn't it? Almost now.
This is a friendly reminder. Please review the list of your telepath testing, and if you have any students, please send them and report to the CC lab. Thank you.
Anybody in here think they could be a telepath student?
Wait, what? What's that?
If you don't know what it is, then it's not you. Everybody who takes the test, they usually know why they're taking it. It's a state test. It's to test bilingual ed. The state wants us to keep track of students who don't start in the school system with 100% English. You what? Really? I mean, the one on the computer? The last one?
I already took it.
And you still, this year?
Yeah,
Okay.
But ever since, like, I always take it, and now I make a pass.
Demonstrate what I was saying about the asymptote. If I choose to zoom in, look at all that room that's between them. Yeah, exactly. You might say, well, that's because I zoomed in. Well, yes, but even if I make it smaller and go through, look at that. It looks like I'm touching it.
It's like depending on the hold.
What's that?
It's like depending on the hold, all the soil.
Oh, yes. But look at the farther away I go, it looks like I'm touching the x-axis, doesn't it? But as you zoom in, you can see I'm not. Well, what if I draw farther in? Okay, and I'm not a good artist, so you know what's going to happen. I'm going to probably accidentally touch it. But let's see. Let me extend my x-axis for a minute. And I'll try to draw my function as close as I can get and say, am I touching it yet? Let me go and look. Yeah, I messed up. I knew I wouldn't be able to do it. Well, over here, look at that. I'll go over here, look at that. There's still room. Okay? Even though, obviously, to the left of it, I couldn't tell. But there's always going to be room. Always. That's what an asymptote is really about. So since we're going to start graphing now, and if you wanted to, feel free, pick up your calculator and graph y equals 2 to the x. I want you to verify that it's a growth. How do I know it's a growth? It has a 2, so b is equal to 2, and 2 is greater than 1. So it should be a growth. It should look something like that. So you should know how to graph that. And I forgot what the command to bring up the table. Control T, is it? After you graph it, Control T brings up the table. Is that right? And you can see all the ordered pairs that it used. And there's an ordered pair that's coming up that is going to be in this. Almost every exponential function you look at, go to that table. Do you see 0, 1? 0, 1, is that in the table? Yeah. As long as the function doesn't move left and right and up and down, 0, 1 will always be in the table, unless the function moves. And so that's the only point I really care about. But since I'm looking at it, and you got a table going on, what happens when x is a 3? Right here, a 3. What does that table show? Yeah, I know, but what's the number, though, in the table when x is 3? 8. How do we know it's an 8? Because if I made a table and I plugged in a 0, I get a 1, because 2 to the 0, anything to the 0 power is always 1. If I plugged in a 3, that's 2 to the 3, which is 8. So I go to my 3 and I go count up 8. 1, 2, 3, 4, 5, 6, 7, 8. Why do you think that's the biggest one I chose? Because if you say 4, what's the y value of 4? It's probably too big. What's 2 to the 4? It's on the table. Now here, I'm talking about the table, and if you're not going to look at the table, you're missing out. Yadi, wake up. Keep up with us. What are you doing here? You're not participating. You're just sitting there. You'll be the big one. Well, yeah, but I'm asking you a question. Do you have the table up? Did you press Control T? Oh, then tell me what happens when X is 4. Oh, I asked you to. Control, you got a graph there? Press Control. It's on the left-hand side. T. Yes. Nurse. All right, so X is 4. There's a reason I didn't use 4. What's the Y value? How much? At 4. It's not, I don't know what you're saying. What's the Y value when X is 4? If you're not going to co-op 16, let me see if you're right. When X is 4, 2 to the 4 is 2 times 2 times 2 times 2. That's 4 times 4. That's a 16. But 16 can't fit on the graph. It only went up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'd have to just keep going 11, 12, 13, 14, 15, 16, way up there, which is fine, you know. At least that tells you something. Now let's do one negative number. Let's do at least one negative. Do negative 3 then. That's right here, negative 3. What's the table say for negative 3? It will be a decimal. Yeah, 0.125, because, let me teach you something. If you have 2 to the negative 3, in Algebra 1, you were supposed to realize what a negative exponent does. That it forces the 2 downstairs. It makes this go downstairs and becomes 1 over 2 to the 3. And we already said 2 to the 3 is 8, so the fraction is 1 over 8, which is what the calculator said, equal to 0.125. So if I go here, that is so small that I can't even tell where it is. I'll just put it right here. Not touching the x-axis though. It'll never touch the x-axis. So here's what I want you to do. Now that I've gotten 1 point to the right here, 1 point to the left, right here, and 0, 1, I'm going to draw a smooth curve. Coming from the right, here goes. Smooth curve. Coming, here it goes, there it goes. Through there, go up here. And now from here, it's just going to go up very steep. So, and I'm going to put arrows on both sides. There's my graph. But in reality, that's a lot of detail that I'm not going to do all the time. But I can draw it faster without doing all of those details. Like, I didn't really need Kayleen to tell me that at negative 3 it was a decimal number. I knew it was going to be a decimal number because this x equals, or this y equals to 0 right here is my asymptote. The red function wants to cross it, but it can't. Once this red function starts falling down, I can't hit the line. I got to stay on top forever and ever and ever and ever. Okay? So on the right-hand side, we talk about some characteristics. And you don't need a perfect graph to be able to answer all of these. For instance, the domain. The domain is the same every single time. The domain means what x's can I use? Well, I could have used any x I wanted. It just so happened that when I used a 4, it was off the chart. And the reason I didn't do a negative 10, I could have used a negative, well, where's 10 at? Or negative, I'll do negative 20. I could have used a negative 20, but it's going to be so small of a decimal that you're not going to care about it. So I can use any x I want. I could use x is 15 if I wanted to, but it's going to be so far up that I won't be able to find it. So the domain is all real numbers. Almost every single time, actually, not almost, it will be all real numbers. sign in. It is now 8:52. That's the domain. Any x you want to plug in works. Now the range are all your y values. Look at that graph very closely. Will the y's ever be negative? You mean it's going to cross the x-axis? Look at it. Does it look like it's going to cross the x-axis? It can't cross the x-axis. The x-axis is called the asymptote. The function cannot cross it. It cannot touch it. I don't think it asks for the asymptote. Oh, yeah, it does down here. The asymptote is the equation y equals to 0. That means you cannot cross it. Everything has to be above it in this particular picture. Can the y value go up to 16? Hello? Can the y value be a 16 up here?
Yeah.
It can be. It can cross any y value we need it to cross at 15 or 16. It was 2 to the 4 gave us a 16. Yeah, it can be 16. Can it be 100? Can I go all the way up to 100 and it be up here?
Yes.
Some x will give me 100. Maybe 2 to the 6th or 2 to the 7th. I don't know. So what we say is this. This is very careful. Be careful here. I want to use a parenthesis and say 0 because parenthesis means it cannot include the 0, comma. I can go as high as I want. My friend is called infinity. Infinity. It's a sideways 8. That means in English, all real numbers greater than 0. That's what it means. All real numbers greater than 0. Could you have written all real numbers greater than 0? It'd be correct. But the shortcut is this parenthesis, and then, oh wait, I messed up. Did I tell you another parenthesis? They're in parentheses because you can't be a 0, and there's no number called infinity, so you'll never be there either. So we put it in parentheses, 0 to infinity in parentheses, which means all real numbers greater than 0. All right, end behavior. This is very interesting. What's end behavior? The end result. Yes, and we have two ends. You have a left end and you have a right end. And so what we're doing here, look at the magic way he's writing it. As x goes to infinity. Wow, that means don't write this out, but here I go. I'm going to keep going this way. Keep going this way. X is going to infinity. Bigger and bigger and bigger and bigger. How high will the function go when I'm way over there?
Infinity.
Yes, sir, that's absolutely right. As you go to infinity, the y values go up to infinity, which means I can never get there. So good job, Dylan. That's what this says. Well, a good person isn't required to be a good student.
Yeah.
You just got to be paying attention. Let's see. Why did that blur like that for me? That is so weird. I must have hit something. I was just trying to erase and it was blurring it. Look at that. I got something clicked that I don't know what's clicked. I'm looking again. Hold on here. I got to figure it out. Oh, I see it. I never knew that's what that was. You can't see what I'm doing, but let's see. Oh, it's still blurring everything. How did it do that? Oh, there. No, I don't know why it's doing it. Sorry, it's just messing me up. I keep getting blurry. Okay, I can't erase now. Dumb program.
Can I go to the restroom?
Someone just left.
Okay.
Doesn't matter how what I hit on this thing. Wow, I don't want to erase my writing on there. I didn't know I could actually do that. Smear it. Oh, well, maybe. That is so odd. Let's see. Can I do this? Yeah. Okay. Can I erase this? Yes. That's fine. Okay. That works. Okay. I think it might be working again. So y equals to, actually, I think it did blur it, but y, not that pen. Y equals to 0. All right. Try to erase this. I need to erase this. I need my room. There. Okay. Oh, man. It's still blurry.
So let me know when you're ready.
I'm ready. I'm just going to write over it. As x goes to the right forever, that's what it means to be infinity. Look at your paper. Your paper should say, there it is, came back again. Infinity. F of x goes where? And Dylan said, that means my y values. How high will I go? To infinity.
True. Yeah.
All right, now look at here. As x goes to the left forever. See the negative infinity? That means this way, negative infinity. As I go this way forever, where does it look like the red line, the red graph is going? How far down is it approaching? It'll never get there, but it's getting close to it. Think asymptote.
0.
Very good.
Oh, I
Are you guys going to let Dylan get all the glory?
got it.
0.
I need extra guess on that.
Well, the asymptote was at 0, right? So we read it as x goes to the right forever, the y values will go up to infinity. That's what infinity means. It means forever, doesn't it? As x goes to negative infinity, that means the left forever, the function approaches 0. Now I'm going to ask you one word, see if any of you were paying attention. Why does it only approach the 0? Why can't it go farther down? Ladies, are you talking about the problem? I want to know, why does it only approach 0 but never get there? Why does it approach 0 but never farther down or farther up that way? It's approaching, what is that line called that it can never touch? What's the fancy word that starts with letter A? Asymptote. Asymptote.
Trying to see it.
It cannot cross the asymptote, but it gets closer and closer and closer as we'd have to zoom in forever and ever and ever, okay? Anything else? Oh, I need my y-intercept. That was the first point I graphed. It's when the point has to be when the x is 0. When the x is 0. What happened when x was 0? I have it in the graph. I marked it. I marked it right here. What's that ordered pair? That blue dot. Is it a 2? Well, my big dot might look like... Go to your table and look. Go to your table and look. When x is 0, what was the value? Because it was 2 to the 0. What is 2 to the 0? 1. 0, 1 was called the y-intercept. Does it have an x-intercept? He didn't ask for it. I wonder why.
Don't have it.
Why doesn't it have one? It cannot touch the x-axis, can it? It's undefined, exactly. All right, so there's your first basic one. Let's see. Now, do you notice number 2 looks very similar to number 1? Right? Instead of a 2, it's a 3. Do you think it's going to look any different? Go ahead, erase the first equation and graph the second one on your calculator. 3 to the x. Change it to 3 to the x. While you do it, was I doing it? Yeah, okay, I've got 0, 1, and 1, 3. 0, 1 is here. 1, 3 is here. Why do I not need any points to the left? We know what's going to happen, don't you?
It's infinite.
That's going to go up forever. What is it doing to the left? It's approaching what? The asymptote. That's an asymptote. Still at, since he's going to ask us, it's still going to be the same number. Y equals to 0. Okay, I'm looking at that picture. I already told you what domain was. If I don't have at least 6 people tell me what the domain is when I count to 3, it means I'm just wasting my time. Domain.
0.
No. See, I even said it out loud at number 1. I said the domain is always going to be all real numbers.
I was trying to see if you
Yeah.
We were testing you.
Did I pass? Yeah, you tested me to see if I was a
If you were like,
loser, that I actually thought you were listening.
thought you were like a fraud.
And there's a symbol for all real numbers if you want to do that. It's a fancy R. Or that's one way of saying it, or you can say all real numbers, right? Or you could do this. Check this out. Parenthesis, negative infinity, comma, infinity. Also means the same thing. So if you were paying attention, you might actually learn something, that this means all real numbers. You could say all real numbers. You could also say from negative infinity to infinity with parentheses. Also means all real numbers. Now look very carefully at the range. What y values would be in the table? If I was making a table with a whole bunch of y values, what kind of y value would you never see? You would never see the negatives. You also, not the y, not negative. You would see decimals, you're right. Positive decimals, right? Would you ever see 0?
Yes.
yes.
You would.
Why would you see a 0? When will the function ever cross the axis? This is called an asymptote right here.
You would say 1.
That's an asymptote. You'd see a 1. I have the 0, 1. Yep. I have the 1, 3. But you will never see a 0 there. Never. Yeah, it can't get there.
Yeah, because that's.
And if you can't touch the y is 0, then you can't cross it. So you're not going to see nothing down here, nothing down there. So again, the answer is going to be parenthesis. The lowest I can go is 0 approaching it. That's why I use a parenthesis, because I can't get to it. If I could get to it, I would use a bracket. But I can't use a bracket because it'll never get there. Comma, how high can it go?
1.
No, higher.
Infinity.
Infinity with another parenthesis. Basically, 1 and 2 have the same answers for domain and range. Domain will always be this. The range will not always be this, because you got to identify where is the asymptote. And you got lucky. Both of those graphs had the same asymptote. Let's finish this up. Now, don't let Dylan get all the glory. As x goes to the right forever, what do the y values become? In other words, how high will it go? Or how low will it go? How high will I go as I go to the right? Forever.
Infinity.
Infinity. What about, exactly, what about as x's go to the left? It's approaching, the arrow means approaching a zero. Will it ever get there?
No.
Will it approach it? Yes, it will. Even as close as 0.0000000000000000036.
Yeah.
It will approach it. How about the y-intercept? Do I know the y-intercept?
What's it called?
It's
y equals 0. Oh, no.
always when the x is 0,
And then
1.
Yeah.
So here are two very basic exponential functions. Now, you know what she's going to do to us? She's going to make us do a hard one. Yeah. Nobody's at the restroom right now? Pass came back? I guess I'm just thinking of Yadi going to the nurse. Yeah, if the pass is there, you can go.
You can go. Yeah.
Right, let's move to number 3. Now, number 3, this base right here, right there at the base of the parent function is considered the B number, and it is equal to 1/3, 1/2, to less than 1. That makes it a decay. That's different than the two growths that we just had. So a decay is going to be falling, okay? And we're going to do the same table. Let's do a same kind of table. And I always want to use x equals to 0 for my parent, because when I say 1/2 all to the 0, anything to the 0 is 1. So 0, 1 is definitely a point that I'm interested in. Now, I'm not going to concentrate on what's happening to the right, because as it goes to the right, as I'm demonstrating right here, it's going to be leveling out to the asymptote. And since this function has not been translated up or down, because I've never taught that to you yet, then I know that as it comes from the left, it's riding the asymptote this way, but it's better to talk about from left to right. So the function's falling down through the 0, 1, and it's going to approach the asymptote. Now, it would be helpful to have a point somewhere up in here. Hold on here. A point somewhere up in there. Somewhere in there. So let's pick an x that is negative. You got your calculators. You literally can plug in it in your calculator. If I say let x be a -2, let's say. A -3 works just as good, too, if you want to do a -3. But when I do a -2, that turns into the fraction of 1/2 raised to the -2. And what is the mathematics of that -2 again? I will review it again with you. When you see a fraction with a power, you first have to understand that means the 1 gets the -2 and the 2 gets a -2. And because this negative we're not allowed to use negative exponents. We use them, but we have to turn them into positive by this whole thing goes downstairs, becomes a 1 to the +2, and then this whole thing goes upstairs, becoming a 2 to the +2, and that turns into a 4 over a 1, which is a 4. And your calculator would also give you the same answer, so that's going to give me a 4. So at -2, I have a 4. Let's see how close I was. 1, 2, 1, 2, 3, 4. That wasn't bad. That's where it should be. So I will erase the evidence that I was not steep enough there. And then I'll continue my ride the asymptote, go through 0, 1, go through the -2, 4, and keep going. There it is. That's a pretty good picture. And a lot of these answers are the same. The domain is still all reals. The range, though, the lowest it goes is starting at this asymptote, and then it goes up forever. So we say asymptote is 0, up forever. The left hand, the end behavior, as x gets bigger, that means as x goes to the right, that's where you get a positive infinity going this way, x is going that way. The y values, obviously the y values aren't moving. They're not moving up or down. I lied. It's slowly moving down, but it's approaching this asymptote. Let me highlight it again here. This asymptote, which is at the line y equals to 0. So let me write that asymptote, y is 0. And so as I'm approaching to the right forever, I'm approaching the asymptote. As I approach to the left forever, that's what negative infinity means, left. You can see that the function's climbing. How high will it go? It'll go to infinity. And the y-intercept? Well, we found it earlier. It's what happens when the x was 0. That's why I did it. That is always, when x is 0, is your y-intercept, so it's 0, 1. Okay, let's try another parent. It's another fraction. The base is another fraction. So if the b is another fraction of 2/3, and this fraction has to be less than 1, it's also a decay. This is going to look almost the same as number 3. I don't have to think that hard. Make my little table. Definitely got to use x is 0. And we all know that 2/3, that whole thing to the 0 power is a 1. So 0, 1 becomes my y-intercept. Hey, while I'm at it, let me go put that there. 0, 1. And since this function is not moving up or down, my asymptote stays the same. Y equals to 0. Okay. Now I feel like I'm cooking with gas. And let's see. It's a decay, so I know again it is falling. So what I'm going to do is pick a number at the left. I'm going to pick, I'll put a -3. Let me see what's happening at -1, -2, -3. Let's see what's happening on this line right here. Let's see what's happening there. So I'm not going to keep that dotted line there, but it's where I'm looking. Whoop. Yeah. So let's try to the left is a -3, and that gives me 2/3 to the -3 power. Well, that -3 applies to both, so it really turns into the 3 goes upstairs, keeps the 3, and the 2 goes downstairs, becomes a +3. That turns into a 3 times 3 times 3, 27. 2 times 2 times 2 is 8. What do I know about 27 over 28? It is greater than a 3, because 3 times 8 is 24. So it's going to be a little bigger than 3. So I'm going to go over here, go back to my -3, and I'm going to go up to the 3, 1, 2, 3, and a little more. So it's somewhere in there. And I have my 0, 1 right here. What happens to the right? Well, it's a decay. So look what's going to happen. Here it goes. Fall down. Go through that point, go through this point. Once I go through this point, aim for the asymptote and ride the asymptote forever and ever and ever, okay? So let's see. What's my domain? Again, from -infinity to infinity. What's my range? Well, the lowest I can go is at this asymptote. It's approaching it. It never gets there. So that's a 0. How high will it go? Well, it goes up forever, infinity. End behavior, same answers as the last problem. As x goes to the right forever, I'm approaching the asymptote, 0. As x goes to the left forever, let's see, left forever, oh, look at that. It's flying high. It's going up, 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 up. That's infinity. And we already have the 0, comma 1 right here. We already have the y is 0. That one's done. Last one. Oh, it's a fraction again. But b is 5/2, but this time it's greater than 1. So this one is a growth. A growth looks like this. It starts low and it grows up, okay? So how am I going to use this? Let's see. Let me get some points. Always use the 0. And anything to the 0 power is a 1. 0, 1. Where have I heard that answer before? 0, 1. A lot today. And since I know it's going to go from the left, it's going to be leveling at the asymptote, by the way, which is 0. I don't need any numbers from the left. It's kind of a lot of work to get a number from the left. I need to know what the numbers are to the right. So I need to pick one number that's in this little world here. Can I think of a good one? I can't really. I think they're all going to be kind of not pretty. So let me just try and see what happens at a 2. 5/2 to the 2 means 5 squared over 2 squared. That means 25 over 4, which is approximately a 6, but it's bigger. It's actually bigger than 6 because 6 times 4 is 24. So your calculator can give me a decimal. It won't really matter. You're still going to tell me 6 point something. So let me go over here. Let me go over to the 2. Here goes. 1, 2, 1, 2, 3, 4, 5, 6, something about here. That's good enough because I know what's going to happen. I know my asymptote is here. So the function's going to be writing the asymptote from the left, writing the asymptote, close, close, close. Get up to the 0, 1, go up, climb, 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 go through the 2, 6 approximately, and keep climbing. There's my growth. So here it is, domain, all real numbers. You can say it, you can write all real numbers, or you can say the fancy R, or you can say negative infinity to infinity. That works as well. Range, well, unfortunately, it never gets lower than the 0. It never even touches 0. So we approach it. That means does not include 0, but it does go up forever. The end behavior, just take a look at it. As I go left, it's going towards the asymptote. As I go right, it's going up forever. So I write. As I go to the right, because that's positive, I go up forever. As I go left, that's why it's negative infinity, left, I approach the asymptote of 0, which leads me to remember that y equals to 0 is your horizontal asymptote. And the y-intercept, let me look again. Oh, it was that dot that I put right here. It was the 0, 1. 0, 1. And then we move on to what if we transform these functions? We're going to make these functions go up and down and left and right. We're going to squeeze them. What am I doing there? We're going to squeeze them. We're going to make them get fat. We're going to make them get skinny. And we're going to use the parent function right here. The parent function is right here, but we have some other numbers that will be there. The number in front of B is my A. And you're going to see that A has a description here, here, and here. And what we'll do is we'll talk about what that A does. And then there's a number that is being connected to the X right here. That's called my H. H is going to be explained here. And then we have this number on the outside right here. That's my K. And K is going to be talked about right here. That's the second part of this lesson that we started on 318. But I will do it as a separate video. All right, guys. Thank you.